So the last time we started to look at matrices and vectors and matrices. So we continue from where we stopped the last time. So I believe the last time we looked at how we can delete a section of a matrix. Okay. So before we really move on today, I want to show us how we can manage the screen. So let's say you have several things you want to type and you think it won't be visible enough, or a line will not contain what you want to type. You can use what is called ellipsis, 3 dots together, to show that I'm not done with my line of thought. There is a continuation. What does this mean? For example, let's say you were using the window command. You know, once you press enter, it's going to compute for you, right? But this time around, you have not finished your line of thought. So how does MATLAB know that you haven't finished your line of thought even though you want to press enter? So you supply ellipsis before you press enter. So it knows that you are still in the process of supplying the information. So once you are done, you stop putting ellipsis and you press your enter the normal way you would have done. Okay. Then another thing I want to point out with this example is that when we want to create a matrix, we did created matrix and vectors the last time. You can also do some computation in supplying the elements. The previous example, we just supplied what values are inside the vector or inside the matrix. But I want to tell you that in supplying the element, there could be arithmetic operation ongoing in the way you supply it. So that's what this example is about. So let's implement it so that you know that this works. Okay. So we said this is hands-on. So as I'm typing mine, you also type yours. Okay, so that we can see that this works. So we want to create a matrix Q. It's supposed to be a 3 by 3 matrix, right? Okay, so the elements are what are shown there. Now when we put a semicolon, we said a row is finished, then we are moving to the next row. So that means what we listed first before the semicolon, the first semicolon, is the element of the first row. So after the first column, what we list there is the element of the second row. Then we put another semicolon followed by ellipsis. That is, we haven't finished our line of thought. Then what is listed below is the element of the third row. So you see some arithmetic operation ongoing. So you see there is a variable x there. So if we want to really get a value for matrix Q, that means we need to supply x. The computer has to know what x is. So maybe we start by putting a value to x. So we make x a variable, we supply a value to it so that we can get an outcome for this. So let's say x is 2 in this case, hypothetical. I want to put a semicolon because I don't need it being displayed on my command window. So I'm creating matrix Q. Which is equal to, so this is a matrix I'm creating, right? So what do? The first thing is that we supply, you open a parenthesis, a square bracket. So what do I have in that square bracket? The first element is 4/5. That's an arithmetic, right? What's the next one? The next one is 7.23 multiplied by tan x. Now we have worked on inbuilt function, so this is not new to you. So this is tan. You open your parentheses and you supply the argument. The argument here is x. Okay. So what's the third element? It's also using a built-in function. So square root of 6. So how do we get square root? SQRT. Open the parentheses and supply. What are we getting? What square root are we getting? The square root of 6. So that is it for the first row. So how do I tell MATLAB that I'm done with the first row? I put a semicolon. But that's not all. I want to continue my line of thought in the next line. So I don't need it giving me a value now. So I put 3 dots, ellipsis, before I press my enter. What happened? Okay, the bracket isn't complete, is it? Okay. Okay, my bracket wasn't complete, right? It's because I'm not using scripts. So let's move to the next line. What's the first element in the second row? 1 over x squared. So 1 slash x raised to the power 2. So what's the next one? The next one is 0. The next one is 3 slash, so there is a parenthesis there, x multiplied by what? Log of x. Okay, so I complete the bracket now, parenthesis. But before the parentheses, I must tell you that I am done with that row, so there should be a semicolon, right? Okay, press enter. What's happening here? Do I mean okay, let me start all over and see what has gone wrong. Q is equal to 4 over 5, 7.23 times tan x, square root of 6, semicolon. Oh, semicolon was wrongly placed. Okay. 1 over x squared, 0, 3 over x times log x. I think this should work now. Okay. X minus 7 followed by square roots of 3, and the last value on the third row is x multiplied by sine x. So I believe we have supplied all of the elements for each of the rows. Have we? So now we can close the parentheses. There's what? Oh, thank you. So that we don't run into another error. I don't need MATLAB shouting at me this morning. Okay. So let's press enter and see what happens. So it gives us results. So what I've shown you with this example is that you can carry out arithmetic while supplying the elements of an array. You can use built-in functions. You can use built-in constants. And when you are not done with your line of thought, you can use ellipses to indicate that this following line is still part of what I'm constructing. Okay, so that's what we have shown this morning. Any question on that? How many of you are able to do this? Okay, so let's move on to the next thing. So yeah, the last time we did create vectors, we created matrices. So now let's look at shortcuts for doing this. There should be some shortcut for some things. Okay, so let's say you want to create a vector that has to a vector that starts from 1 to, let's say, 100, and let's say maybe the interval is 1 1. No, you can't begin. It will be laborious for you to type 1 followed by 2 followed by 3 until you get to 100. So there is a way around that. So what you could do is, if you are creating a vector using shorthand method, you can use the column operator to create range of values that are separated by 1. By default, MATLAB believes that if you are creating a vector, you just supply the starting point and the end point, and you separate the two with a column. So if you are doing that, you don't need to put the square bracket that we used to use to create maybe a vector or matrix, since you are using the column vector to get your vector, the column operator to get your vector this time around. So you do without the square bracket. So if you are using the column operator to get your vector, by default, the interval is going to be 1, 1 for MATLAB. So let's try that. So let's try and create a matrix Y that starts from 5 and ends at 8 using the column operator as you have seen on the screen. Okay, so we have that created. So instead of you typing from 1 to whatsoever you are going, just do that. So since you have done this example with me, I think you can leave the exercise until your study time. Now let's say the interval is not going to be 1. You have other intervals in your mind. Yes, there is a way you can do that, also using the column operator. You know what you did before was that my start point, I use a column point to separate it from my end point. So this time around, there is something that is going to be in between the start point and the end point. So that's going to be the interval that you actually want. So let's say you want the interval now to be 0.1 instead of 1 that we had the other time. So what you do is that the start point, column operator, followed by the interval you are looking at, column operator, followed by the last value or the last element. So let's recreate X such that we are starting from 0 and we are ending at 5, and we want the interval between the elements that we are creating for that vector X to be 0.1. Let's try that. Oh, remove the semicolon in your own case, please, so that you can see what has been done. Okay, you see that it's massive. That's about 51 elements. So imagine you are typing this one at a time. Number one, it is error prone. Okay, and it's time consuming. At least you spend nothing less than 15 minutes writing this one at a time if you are so much concentrated on it, right? Okay, but now we have done this in seconds. Okay, so let's try and create another X, array of X. This time around, we are starting from 10, and we want the end value to be 11, and the interval between 10 and 11 should be 0.3. So let's see what happens here. 0.3. From 10, we are going to 11. The interval between should be 0.3. Don't put semicolon so that you don't suppress it, you see the outcome. So what can you say to this result? Is not included. So what that means is there is a limitation to this approach. So you are the one supplying, this is the interval I want. So with this approach, the last element, inclusion of the last element is not guaranteed. So what if you actually want the first element and the last element to be there? There is a way to that. So we see that now. So the next approach is to use the line space function. The line space function. What this does is that it takes the first element from you and the second element from you. So this time around, you are separating with a comma. Then the third input is going to be how many elements am I looking at? So you have to determine the number of elements that you want to be in your vector. So once you supply the number of elements you want to be in your vector, MATLAB is going to do the computation such that it calculates what the interval is going to be and ensures that the first element and the last element are included. Okay. So this is also going to create a linearly spaced vector for you. So let's try that. So now we want to create a vector that starts from 0, ends at 1, and has 5 elements. So we say x, which is our vector to be, is equal to line space, L-I-N-S-P-A-C-E. You open a parenthesis and supply the argument. The argument is the first element followed by the last element followed by the number of elements you are looking at. Each of these arguments separated by a comma. Have you tried it? Do you have outcomes? Okay. So we have looked at 2 shorthand methods for creating vectors. But you notice that what we have created were row vectors. So someone might say, I want a column vector. How do I get that? From this shorthand method approach that we are using. So the last time we said we looked at the way of converting row vector to column vector. One thing you can do is that if you want all of the elements that was inside the row vector, you want all of that element to be converted to a column vector. What you just do is that variable, which was a row vector, you open a parenthesis and supply column. So it's going to return all of the element that was in that row vector. It's going to supply it to you as a vector that is a column vector. That's one way. Then another way is to use your apostrophe, right? So that variable you want to convert to a vector, you just put an apostrophe after it, and it converts it to your column vector. So the same way, the input that we have used for our row vector, you can have the same input and just ensure that you use things that you can use to convert it to a column vector. And we also added a step the other time that instead of doing it multi-step, you can open a bracket so that what you want to do actually happens within the bracket, constructing the row vector. Then you put maybe the parentheses, the apostrophe outside. I hope you remember. So let's try that. So let's say we are creating a row vector that starts from 1 to 3. So we have that. So we can convert it into a column vector by just putting an apostrophe like this. That works. And let's try this. Is this giving you result? Yeah. Okay, so that works. So that means with the column operator to create your vector, you can use this route to limit the steps that you take to get your column vector. I hope you get what I'm saying. Now let me recreate B. Recreating B using what I wanted to use before. Okay. Comma separated. Then I want 5 elements. Yes? Oh, I think that was what went wrong. We didn't include line spacing. Okay, thank you. Line space. Is it complete now? Okay. So now let's insert our bracket again. The outside brackets. Line space 1, 10, 5. Yeah, I think the argument is complete. Okay, so that was what we were supposed to do the other time. So this should still create the vector for us. Right? Let's try. Okay. So the rule is general. Whatsoever you put in the parentheses gets calculated first before the outer operation. So we missed the function that was to create the vector for us the other time. So I still want to recreate B anyways. So in recreating B, I want it to be a row vector actually. Okay. So this is a row vector. So I can convert it to a column vector by saying B column, then I close the parentheses. Right? You know, this will get me B as a column matrix. Okay. So now what we've looked at is you can compress the step that is involved in getting a column vector. You can compress the step, even though you are going to be using the approach that gets you row column, but you can include what will get you the column vector in a go. That being said, then you could use the column operator to convert a row vector into a column vector. I think that's the idea we are trying to show here. So let's move to another thing. Yeah, we've touched on this. So do you want to carry out the exercise? You are creating a variable. The name is theta. Any name that is valid. And in that you have 10 elements. So when you are specifying the element, you are the one specifying the element. You know that it comes last, right? And you'll be using line space as the function. You don't forget that, even though you might be in a hurry. Okay? Then you are starting from 0 and ending at 2 pi. So that means you are separating 0 and 2 pi with a comma, followed by a comma and 10, which is the number of elements you are looking at. So by doing 2 pi, number one, you are carrying out operation within the process of getting your vector, and also you are accessing built-in constant that we have done before now. Anyone trying that? Okay, that's fast. Anyway, I'm combining mine with talking. Thank you. Line space is very important. That is what actually creates the function. Line space into 0, 2 pi, 10. Close the parentheses, and I should get some answer. So that's 10 columns. So I didn't have to be typing it one at a time. So as we have seen some shortcuts that will be very useful, very handy to you when you are working with vectors, we should also look at ways that we can quickly generate some special or let's say elementary matrices. Okay, for example, you might want to generate a matrix that has 1 in the diagonal matrix. In its diagonal, that every other element is 0. I think you have come across something like that, that every other element is 0, but the diagonal elements are 1. So you may want to get that. So there is a shortcut for getting that. So you use the function I, EYI. Okay. So for every function, you put in the argument. So the argument can be 1 or 2. You know, when you are creating matrix, you need to tell us how many number of rows, how many number of columns. You separate it by a comma, row, comma, column. So if you are supplying 2 arguments, let's say 2, 1, so you are telling that you are creating a matrix that is 2 by 1, 2 rows, 1 column. If you supplied 3, 2, you are saying 3 rows, 2 columns. But if you just supply only 1 value, yes, it will accept it, but we believe that you want to create a square matrix. Okay? So if it's only zeros that you want inside the matrix, so the function to use is zeros. So the explanation is still the same for, are you looking at a square matrix or you are looking at a m by n matrix. So if you want all of the elements to be 1, so the function to use is ones, O-N-E-S. So if what you want to do is to access the diagonal elements of a matrix, let's say you have a matrix called A, and you are interested in getting the diagonal element. So what you just do is to use diag into the name of that matrix, diag, D-I-A-G, as seen on the screen. Then we have used random before. Why? When I was teaching you how you can teach yourself MATLAB. So rand is to create for you random numbers. It's to create for you random matrix. So it's going to just put random values inside the matrix. And if you are supplying m, n, so that means you are specifying that, okay, I want so number of rows, so number of columns. But if you supply only one value, it's going to return a square matrix of random numbers. So let's try and implement that. So let's create a matrix 2 by 2 with random numbers. So the random numbers, if you are using rand, it's going to be between, if you are just using rand the way it is, it's going to supply you values between 0 and 1. But if you want something more than 1, you can look at the function rand to know how to configure that. So have you tried x equals to rand 2? So it's going to generate a 2 by 2 matrix for you. And the number in it is going to be, the element is going to range from 0 to 1, and it's going to be random. So what you get will be different from what I get. So don't bother if you don't get the exact values that is in my notes, because it is random. Okay? So we have created a square matrix. So let's say we want it to be a 2 by 3 matrix of random numbers. Why are we doing this? You are already aware that this can be done. So when you need it in your computation, in your analysis and all of that, you know how to generate what you need for the process. To be whole numbers. So I already said that you look at the documentation to see how that can be done. So it's actually possible. 2, 3. So what do you have? Do you have a 2 by 3 matrix? Okay. So you see it's randomly generated. What I'm having on my MATLAB window is different from what is in my node. But what is key there is that I am getting a 2 by 3 matrix, and the range of the element is between 0 and 1. None is below 0, none is above 1. Okay, so let's say I'm interested in getting a 2 by 3 matrix and all of the elements is 1. So what do? ONES into brackets 2, 3. So that will generate that for me. And if I want it to be a 2 by 2, I just say 1 into 2. So that's it. Any question again before we move on to another thing? So as we have done for ones, we could have done for any of the listed elementary functions, right, for generating matrix. So we don't need to, okay, we just need to get the concept. We don't need to practice all of the possible examples, and that is not even possible. So now there is something called concatenation. So it's combining something together. So we can carry out concatenation for matrices. So how does it work? So if you have a matrix that has n number of rows, and you have another matrix that has n number of rows, so that means their number of rows is equal. So you can concatenate them in such a way that you can put them sideways. It's possible for you to put them sideways and it will make sense. Okay, so if the number of rows are equal for two matrices or more, you can join them side by side. So that's what they call horizontal matrix. So when you want to put elements side by side, how do we do that? From what we have done so far, creating matrices. We use comma or space because it's just like we are listing them, that this. So you are separating them either with a comma or with space. So that's how they will be side by side. So if the number of rows is equal, you can join them side by side, put them side by side using space or comma. Okay. Then we'll move to vertical concatenation. So if the width of the matrix is equal, of the matrices are equal, if the width of the matrices is equal, okay, what you can do is that you can put one over the other. So what do I mean by the width? The number of columns are the same. So that means you can put one over the other. So that's what we call the vertical concatenation. So it's just what is possible, what is feasible. You know, it has to be regular in shape at the end of the day when you join them together. So that's what that will guide you in knowing what form of concatenation can I do to this kind of matrix. So you can have a situation that you have to combine both the horizontal and vertical concatenation. So in that wise, so let's say you have a target of creating this matrix where my mouse is hovering, and these are what you have. These are your starting points. So you can look at it that how do I combine them to generate this? So if I look at this, the number of rows for this and this is equal. So I can join them, putting them side by side. That's horizontal concatenation, right? Then these small ones, I can put them together. Also sideways, right? If I put them together sideways, then the number of columns that I will have here will equal to the number that I've created by concatenating these two, right? So that means in that case, the width is now equal to what I have created earlier. Then I can now put them one over the other. Then since this is where I'm going, so I know that this first one comes first, and this other one will follow. Do you get it? So in that wise, I use space to separate these two. I use space to separate these two. Then I use a semicolon to tell you that I want to put this over this. Is it clear? So I have used diagram so that you can visualize it, and when you are working, you know how to concatenate. So you might need to write one or two things down to know, okay, is this, how do I join this? How do I join this to get what I want? So let's apply that. So let's say we want to create a matrix B. Let's say you want to create a matrix B and you have a matrix A as a starting point. So let's imagine that you couldn't see my solution. So what would you have done? You have a matrix A, 1, 2, 3, row 1, 4, 5, 6, row 2, 7, 8, 9, row 3. And you are creating B. So what can you do? What I can see there is that I can concatenate A with a matrix, a matrix A times 10, putting them side by side, because what is after matrix A? If matrix A is an entity, what is after it is just a multiple of matrix A, which is 10 times of A. So I can say 10 multiplied by each of the elements of matrix A, right? So I can concatenate them using space. Okay, so then if I look below matrix A, that row of matrix A, if I look below it, there is also a part that is looking like a derivative of matrix A, but this time around it has been multiplied by -1, right? It has been multiplied by -1. Now, because that is below the row of matrix A, if I want to use that, I'll use semicolon to say that I'm moving to another row. Are you getting it? I'm moving to another row. But I can't just say minus A alone, because it won't balance. There will be some elements that are empty. So that means I need to concatenate another thing to it. And what else can I concatenate with it? You see that there is a part that says 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay, so I can create that. There are two approaches. When I create that, I can concatenate that with the part that says minus A. I can concatenate them side by side, right? I can concatenate them side by side and let them be below the row of A space 10 times A. Okay, so how do I create that part that says 1, 0, 0, 0, 1, 0, 0, 0, 1? How do I create that part? There are two ways to it. I can create a square bracket and supply all of the elements by saying square bracket 1, 0, 0, semicolon, 0, 1, 0, semicolon, 0, 1, 0, 0, 1, right? But based on what we have done today, instead of going that route, I can just say I3. So that's going to give me a 3 by 3 matrix that has 1 in its diagonal. So any route that you take, you will get the answer. Okay? People don't have to take exactly the same way, but based on your experience, you can have different ideas on how to approach a problem. So let's try this. So let's first of all create matrix A. What's in our A? 1 space 2 space 3. Another might say 1, 2, 3. We are still saying the same thing. Semicolon 4 space 5 space 6. Semicolon 7 space 8 space 9. Okay. That's A. So let's get B. B is, so we are creating a matrix, right? So we need the square bracket. So the first input is our A that we have created. So what's the next thing? We are saying 10 multiplied by A. So that will give us the first 3 rows. That's sufficient to give us the first 3 rows. So we want to create the last 3 rows. So let's say a semicolon to say that now we want to move to another row. So what are we having here? So we already see that that's a multiple of A minus 1. Minus 1 times A. So we say minus A concatenated with. So let me quickly use I3. So what do we have? We have what we are looking at, right? So let me use the first approach. So let me clear B now. So let's have B. So what's in our B? We have matrix A followed by 10 multiplied by A semicolon. So we have minus A. So all of this we want to create it as if it's a separate matrix, sort of a separate matrix inside the matrix. So we open another square bracket and say 1 0 0. So that's the elements in row 1. That's the element in row 1. And the next row is what? 0 1 0 1 0. End of row. Then the last row is 0 0 1. So let's close this parenthesis. Then let's close the first parenthesis that we opened. So if we do that, what do we have? We should have the same result as we had. So there is flexibility in anything programming. We can use any route that is valid to get the solution that we are looking for. Okay, so quickly do this exercise before we close the lecture for today. So you want to create that. You have a matrix C and you want to create a matrix D as seen there. Can you try it? Anybody with solution? That should not take long. Okay. What's the question? You have gotten it. Okay. I think you must have used some of the functions we introduced today, right? To make it faster for you. So anybody still doubting can look at my steps. So for the first one, we can create that with what? Zeros into 2 space C that we just created, right? Then we have a semicolon. The next one, how can we create that? We can use ICE2, right? Followed by space. Then how do we get the last one? Once. Okay. Then we close the square bracket. I think that's about it. If there are no errors, it should give me the result. Okay, I. Okay. So we just fetch it and go to I. Delete the S and get it again. Then zeros. Instead of 0, it should be zeros. I typed 0 before. You see, it has guided me. It said undefined functions. So I think you only pick the first error. If I don't correct I, is it high or ice? I. So if I don't correct that I, then will give me that as the next error. So you only pick the first error. So I think this should give us result now. So that means you should be familiar with some of the commands, and if you are not sure, if it gives you error, then it can help you to recollect what it's supposed to be. Okay? Otherwise, if you are connected to the internet, you can just type a keyword, right? That you want to create this you explain, and use doc. So it's going to open it up, and you know what function you're actually looking at. Okay. So let's call it a day today.